We're gonna start chapter 5 today. So the first thing we'll talk about in chapter 5 is a probability distribution. So a probability distribution is a distribution that involves probabilities. So that is an accurate definition, but it's loaded with technical terms. So let's review what this means. So again, this is a distribution that involves probabilities. So first of all, what's a distribution?
Data, how far data is spread apart.
Yeah, very good. So you're looking at your data set, and you're looking at one particular variable, and you're looking at how the values of that variable are distributed in your data set. And you can represent the distribution with a table of 2 columns, that's one way. So, for example, let's say that the variable we're interested in is, we have a hat with numbers in it. And let's say all the numbers in the hat are either the numbers 1, 2, 3, or 4. So when we first started talking about distributions, we started talking about how we would measure how often each value occurred as a frequency or as a raw count. And let's say that each number in the hat was distributed with this particular frequency. And let's say that you were to draw out all the numbers in the hat. Each one occurs this number of times corresponding to the frequency. So the question would be, what is the average number that you draw out? So how would you find it? So what is the mean value of x in this distribution? Yeah.
You multiply the x by frequency, and then you add all the frequencies together.
Yeah, very good. So you add up each of these x values this number of times that corresponds to the frequency. And then you would add everything together, you would divide by the number of numbers, and the number of numbers corresponds to the sum of all the frequencies. So in this case, adding up the 1 5 times would be 1 times 5 plus, you add the 2 up 15 times, or 2 times 15, add the 3 up 30 times, add the 4 up 50 times. And then you would divide by the number of numbers, or in this case, the number of numbers is the sum of all the frequencies. So what would that be?
100.
Yeah, 5 plus 15 plus 30 plus 50 turns out to be 100. And if you punch, so before we punch this in, we're trying to find the mean value of x here. And we don't want to just add up the 4 x values and divide by 4, in which case we would get the midpoint, which ends up to be 2.5. But the actual mean of this, you would expect to be higher than 2.5 or lower? Yeah, why is that?
Because where you have your the higher numbers.
Yeah, you have a lot of 4s here. You have 54s, which is half the data points here, are this highest value of 4. So the average is going to be pulled up towards this highest number that is occurring so often. So you'd expect the average to be much higher than 2.5. And this 2.5 is only true if these 4 numbers are occurring relatively the same number of times. But this 4 is occurring 10 times as often as this 1. So you would expect the average to be pulled towards the higher numbers. So if you actually punch this in, what number do you think you get? 3.25. Good. So as expected, the average is higher than what it would be if these numbers were weighted the same. Okay, so this is a review. This is if you have a distribution that is specifically a frequency distribution, where you're measuring how often the values occurs as frequencies. So in a probability distribution, we're measuring how often the values occurs as probabilities. So, and how often the values occurs, we're measuring how often it occurs as probabilities. So in this case, you could pretty easily convert each of these frequencies into probabilities. So if this number occurs at a frequency of 5 times out of 100, what would its probability be? Yeah, so this number 1 is occurring 5 times out of 100, so its probability would be 5 out of 100. You can think of it as the classical definition of probability. So the number of desired events 5 divided by the total 100. So this would be 0.05, and this probability would be 0.15, and so on. So let's say the same question was asked, what is the mean? So would you expect the mean to be the same, 3.25? Yeah, so let's say that you were given just this table of the first column x and the third column the probabilities, and not the numbers in the middle. So would you expect the mean to be the same? 3.25? Yeah, because this first and third column, the third column is coming directly from these raw numbers. So the mean is 3.25 for the raw numbers. The mean should also be the same thing for the probability distribution. So it should be the same. So the way that we calculate the mean, if we had had a probability distribution instead of a frequency distribution, is how do you think the calculation would change? Even though we know that the final answer should be the same. How do you think the calculation changes? So now, again, we don't have this middle column. We only have the first and third column. So let's say that right now we don't have this. So given the first and third columns, how would you calculate the mean so that it ends up being the same number, 3.25? Yeah, so even though, so both the second and third columns here represent the weights. The frequency and the probability just represents how often this number 1 is weighted. So mathematically, it's the same. Even though you have this decimal number, you still multiply the number by its respective weight. So this is going to be 1 times, instead of 5, we're going to multiply by 0.05. And plus 2 times, instead of 15, we're going to multiply by 0.15. Plus 3 times, instead of 30, we're going to multiply by 0.3. And so on. Instead of 50, we're going to multiply by 0.5. And in the end, we divide by the number of numbers. So what do you think we should be dividing by?
1.
Yeah, so mathematically, before we just added up all the values in the second column, the frequencies, but now we just add up all the weights, the probabilities, and these are going to add up to 1, so 0.05 plus 0.15 plus 0.3 plus 0.5, and these just add up to 1. So if you calculate this, you're going to get the same answer for the mean, 3.25. Because these values are just weighted relatively the same way they were before. Any questions? So we call this a probability distribution. If you have a distribution of values where the way that you represent how often values occurs is using a probability as opposed to a frequency. But if you add up all the probabilities, what do you think the probabilities should add up to?
1.
Yeah, so in this case, they add up to 1. Do you think they always add up to 1?
Yes,
Yeah, why is that?
because an entire data set having the probability of each data point, it has to add up to one if you're including all of the points in the data set.
Yeah, excellent. So any probability distribution, by definition, a distribution, you're listing out all possible values. And if you look at all the probabilities of all possible values, they need to add up to 100% or need to add up to 1. So every probability distribution, all the probabilities will add up to 1. And so when you're calculating the mean, the denominator here always adds up to 1. And so dividing by 1 is really, you can ignore it because dividing by 1 is the same as not dividing by 1. So this part you can actually ignore for any probability distribution when you're finding the mean. And so the mean of a probability distribution ends up just being this numerator up here. So we can generalize this. So mean of a probability distribution is simply the top part of this fraction, which is the sum, where each sum, the term of each sum is x times p of x. So each of these sums that are being added has a term that is comprised of x times p of x. So x is an entry in the first column, and p of x is an entry in the other column. So it's simply the sum, and in math, we said that the sum is notated with the symbol, the summation symbol, x times p of x. So this is the mean of a probability distribution. Yeah.
Are we always gonna get the probability distribution, or are we gonna have to figure it out for frequencies?
Be comfortable with both, but usually just the probability distribution will be given, just the probabilities will be given. But again, like an earlier question might be, here are the frequencies, come up with the probability distribution first, in which case you'd have to divide these out first. Okay. So now that we know how to find the mean of a probability distribution, let's go ahead and use an example that might be a little bit more relatable, or at least practical. Let's say that after the semester is over, let's say that we decide to start a business together. And let's say that the business we start is a life insurance company. So the way that life insurance works is that we have paying customers who pay us. And let's say they pay us what we call a premium of, let's say, $110 per year. So each of our customers pays $110 per year. And the way the life insurance works is if they were to pass away, then we owe their family $1 million. But fortunately for this business, most of the time, our customers are not gonna pass away, and then we're gonna just keep collecting this $110 from each customer. So the probability that a customer passes away is gonna be, let's say, 1 in 10,000. So the question is, what is the average profit we can expect from each customer per year? So the question is, what is the average profit per customer per year? So, any suggestions on how to approach this?
you can make like a frequency chart where it's like, one, or you could do like, $1 million and the frequency is 1, and then, or it could be like -1 million, and then for the other side, you could do like, 110 for X, and the frequency is like 9,999.
Okay, good. So if you guys kind of recall from Bayes' theorem, where we kind of constructed a chart and made up numbers to find probabilities, we can definitely do that here. Very good. Any other suggestions? But because we just talked about a probability distribution, and we talked about how to find the mean of that, notice that's basically what we're trying to find here. We're trying to find the average or the mean of some variable. And so basically that's what we're trying to do here. So let's go ahead and construct a probability distribution here in this context. So whatever it is we're trying to find the average for, this will be our variable. So our variable is going to be profit per customer per year, because that's what we're trying to find the average for. So in our distribution, our variable is going to represent the profit per customer per year. And the other column will represent the probability of each of those values occurring. So that would be called P of X. So then in any distribution, we want to list out all the possible values of that variable. So this variable now here represents the profit per customer per year. So what are all the situations that could occur with this customer?
The Heiser doesn't die.
Yeah, either they pass away or they don't pass away. So if they pass away, then what is the value of this variable? What is the profit per customer per year? Yeah, if they pass away, then we owe their family $1 million, so we lose $1 million. So let's make that -$1 million. But technically, we don't lose the full million, right? Because earlier in the year, they paid us $110. So technically, it's gonna be -$1 million plus 110. That's the net amount we actually lose. And what probability does that happen with? What's the probability that that customer passes away?
1 in 10,000.
Yeah, 1 in 10,000, that's given. And then what's the other situation that could happen with the customer? They could live. And what would the value of this variable be in that situation where the variable represents the profit per customer per year? If they live, what's the profit that we make off that customer per year? Yeah, we make the full 110. And what's the probability of that happening? Yeah, it'll be whatever's left over from the previous probability from 100% or from 1. So this will be 1 minus 1 in 10,000. And this will be 9,999 divided by 10,000. So now you have a probability distribution of this variable, and you wanted to find the average value of this variable. So all we do is what we did before, which we multiply the products of each of these rows together, and then we add everything up. And so let's write out the expression for this mean. Again, it will be from this generalized mean for a probability distribution. We're adding up each x times p of x. So x is, in the case of the first row, it'll be -$1 million. its respective probability, which is 1 in 10,000. And then plus the value of the next x value, which is 110, times its respective probability, or 9,999 divided by 10,000. All right, any questions? Okay, so go ahead and punch this in your calculator. Let's see what we get. Yeah. So I heard an answer of 10. You guys getting that? Okay. So what does that mean? Is that good? Should we go into business together?
No.
No.
Yeah, so what does this value mean?
$10 a year.
Yeah, so this is the value, the average value of this variable that represents the profit per customer per year. So this is the average profit you should expect per customer per year. So this doesn't seem like very much, but again, this is per customer. So what happens, what's the total profit we should expect to get? Let's say we had 1 million customers. What would our total profit be? Yeah, it would be 10 times that number, 1 million, it would be 10 million. So this number 10, even though it doesn't seem like a lot, represents the profit per customer, not overall. So if you wanted the number overall, you would multiply this number by the total number of customers. Any questions? And this is on average, so the more customers you have, the more accurate this number will end up being. Okay, so let's look at another example. Okay, so to find the mean of this probability distribution, one way that you could have done it is use this formula that we talked about. The second way that you could have done it is you could have entered in these columns in your calculator, these 4 numbers, and your calculator would have internally calculated this mean for you. So practice doing that as well, where you just enter in these 2 columns of numbers, and your calculator will also give you the mean. And I can show you after class if you don't know how to do that, yeah. Just go to the data portion, just like the way that you, in chapter 3, you found the mean of the standard deviation using the statistics mode of the calculator. So it should be similar to that. The only thing is that some calculators will treat this probability as being a frequency. And it will only expect whole numbers for the frequency. And if you enter in a decimal number as these probabilities, then the calculator might give you an error. But there's a way to get around that. So if that applies to your calculator, then see me after class. Or I'll go ahead and show you now. That might affect a lot of students. So if your calculator doesn't accept a decimal number for the frequencies, because these are probabilities, then one way that you can get around that is there a constant number that you can multiply to both all the numbers in these probabilities here so that they become whole numbers?
10,000.
Yeah, if you multiply both of these by 10,000, you notice they become whole numbers. So multiply by 10,000 here, it becomes one, multiplied by 10,000 here, it becomes 9,999. And if your calculator only accepts whole number frequencies, then enter in these numbers now instead of the original probabilities. And it turns out that you'll get the same mean because these numbers, x values, are just weighted relatively, and these relative weights are actually the same. The second weight is still 9,999 times bigger than the first weight. So you'll get the same mean at the end. Okay. So if you have any questions using your calculator, feel free to see me. So in the second example, let's say that we talk about the state lottery. And let's say it costs $1 a ticket. And the lottery is often sponsored by state governments in order to raise money for the state, in order to pay for common things like education, presumably. So let's say that the probability of winning is 1 in, let's say 13 million. And let's say that the payout if you win is 1 in 7 million, or 7 million. So the question is, from the perspective of the state government that is selling these lottery tickets, what is the average profit or loss that the government can expect per ticket? So again, we're trying to find the average value of some variable here. And the quantity we're trying to find the average of is this profit or loss per ticket. So whatever it is we're trying to find the average of, we're gonna make that our variable in the probability distribution. So we're gonna set up a similar probability distribution as before and find the average. So the variable here will be whatever it is we're trying to find the average of, which is the profit or loss per ticket. And the second column will be the probability of each value occurring. So in any distribution, we want to list out all possible values of that variable. So for each ticket, what are all the scenarios that could happen? Yeah, it's either it's a winning ticket or a losing ticket. So let's say it's a losing ticket first, then winning. So now we just fill out each of these two columns for each of these scenarios. So if it's a losing ticket, then what is the value of this variable that represents the profit or loss per ticket? Okay, so remember profit or loss, we have to be specific in terms of who it's a profit or loss for. It could either be from the standpoint of the customer or from the standpoint of the other side or the government. So in this case, let's say I specify to you that it's a profit or loss from the standpoint of the government. So from the perspective of the government, if it's a losing ticket, then how much does the government make or lose per ticket? If it's a losing ticket, which means that the customer's winning.
Oh,
Okay,
Yeah.
okay. The negative 7 million.
Yeah, if it's a losing ticket, which means that the customer loses, the government is making the dollar, if it's a losing ticket, right? If it's a losing ticket, that means that the customer loses, but from the standpoint of the government is making the full dollar, because it's a losing ticket. So, this will be +1. Government is making a dollar, so what's the probability of that happening?
12,999,909.
Yeah, very good. Probability of a winning ticket is 1 in 13 million, so losing ticket will be 1 minus that, or 12,999,999 divided by 13 million. And then, if it's a winning ticket, then how much money does the government make or lose? Yeah, they have to pay out 13 million, or 7 million, but earlier they made $1 from that ticket. So technically, they lose 7 million minus $1. So it'll be a negative 7 million plus 1, or they lose 6,999,999. And then what's the probability of that happening? Yeah, so probability of a winning ticket is 1 in 13 million. So now that we have a probability distribution, we can find the mean of this variable in the probability distribution, or the mean profit or loss per ticket. So go ahead and either enter in these 2 columns in your calculator, or use this formula that we talked about. So I already filled in the formula. Okay, so one proposed answer is 4.62, and what are the units on that? That would be dollars, right? Okay, so do you think
Wait,
this
no.
answer?
No,
It'd be, 0.462 dollars.
Okay, very good, so let's say that we get started with this, so let's talk about whether this answer, might make sense. So, if this represents the average value that the government makes per ticket, and each ticket only costs $1, can the government make more than $1 for each ticket?
No.
Yeah, no. So that gives us a sense of what the possible answers could be. So we know that the answer can't be more than $1. So, if originally you got this, then you know that you had punched in something wrong. So it turns out that the answer turns out to be .462? Yeah, so it's 46 cents. So that makes more sense, meaning that if the price of a ticket is $1, on average, the government doesn't make the full cost of the ticket, the full dollar. They make only part of it, but still, it's a positive number. So most of the time, they're gonna make the dollar, but once in a blue moon, they're gonna have to pay out $13 million, but it still averages out to a positive profit. Or they have to pay out the $7 million, but it still averages out to a positive profit. Any questions?
Can you just divide 7 by 13 and then subtract it from 1? You get the same answer.
Well, if you take 7 divided by 13 first, and then subtract from 1, you're gonna get a different answer. Is that what you meant? 7 divided by 13 first, and then whatever that is, subtract from 1?
I don't know the way my brain was thinking, but that was just like what I thought of at first before you had everything out, and then I got the same answer.
Yeah, so it turns out that this add 1 or minus 1 contributes, compared to the 7 million, it's so small relatively, so if you didn't do it, you would still get the same answer.
Perfect.
So if you just took 7 million divided by 13 million,
Yeah.
and ignored the minus 1, you'd still get the same answer, because the 1 is so small in comparison to the 7 million.
Okay, but if losing ticket was higher, then it would be a lot different.
Right, if the price of the ticket was a lot higher,
Okay.
if it was thousands of dollars, for example, then it would be.
Okay.
Okay, good. Any other questions? Okay, so let's look at another example. So let's say that we are playing a sweepstakes where instead of there being only one prize, you can win one of several prizes. So let's say, so if you win, you could win either $1,000, and the probability of that would be 1 in 10,000. Or you could win $1 million, and the probability of that would be 1 in 10 million. And the question would be similar to the previous two questions, which would be, what's the average profit or loss for each ticket that you as the customer experience. So per ticket, from the perspective of the customer, versus from your perspective. So previously what we did is we basically constructed a probability distribution, and we found the mean value of that variable x in the probability distribution. And in this case, it kind of looks like we already have a probability distribution laid out for us. So in that case, can we just go ahead and find the mean by finding the product of the rows and then adding them up? Can we just multiply these and add them up?
No.
Yeah, what?
Because we don't know how much we paid to get this chance in the first
Okay,
place.
excellent, excellent. So one giveaway as to the fact that something is missing is that we said that in any probability distribution,
Is it just one or the other, or can we win both as one?
you win one or the other in this example. So one dead giveaway as to the fact that something is missing here is that we said that any probability distribution, all the probabilities need to add up to it. Need to add up to 1. So right now, Do these currently add up to one? No, so that tells you that something is missing here. And that tells you that there's some value here, in the represented as the variable of this probability distribution, some value is missing from that variable. And, so what is it that's missing?
Getting nothing.
Yeah, so this is only if you win for that ticket, but we haven't expounded on what happens if you lose. So that's a big thing. We have to list out all the possibilities for this probability distribution. So if you lose, basically you lose the price that you paid for the ticket. And so that needs to be specified. So let's say that the ticket price is, let's say, $3. So if you lose, that means you lose the full price of the ticket, which is the $3. And we're gonna specify the fact that you lose with a negative sign. And what should that probability then be? What should be that value in the chart?
The complement of those two added up.
Okay, very good. So you know that all the probabilities need to add up to one. So whatever this is, it needs to add up to the other ones to give one. So the value here should be one minus whatever the sum of the previous two values are. So these will all end up adding to one for these probabilities. And now you have a full probability distribution, which you can find the mean for. And so either you enter in these three entries in each column into your calculator, or you can use the formula we talked about, where you're multiplying each row together and then adding those all up. So the mean here will be 1,000 times 1 in 10,000 plus a million times 1 in 10 million plus -3 times whatever this is. So if you have a calculator where you can just enter in the columns of numbers, then it'll save you some time and work. Yeah,
Do you subtract 3 from the 1,000 and the 1 million?
so this will be plus -3 here, and then multiplied by all of this. But technically, it's adding a negative number, which is the same thing as minus.
Well, I mean, like, if you win the $1,000, do you still lose your $3 that you spent to get the ticket?
So any one of these situations could occur, so if you win the $3,000, then you don't lose this, but you still have to account for it when you take the average. So any one of these situations could occur. Just like, when we find the average of, how much we make in the life insurance company, the profit, we still take into account that the person passes away as well as if they don't pass away, even though both don't happen at the same time. Alright, so if you punch this in, somebody let us know what they're doing.
$2 per ticket, maybe 2.2.
Wish you guys got that. So this number then represents the average profit or loss from the perspective of the customer. And it's negative, so what does that mean? It's a loss, so that means on average, every ticket that the customer buys, they're gonna lose money. They're gonna lose $2.20 on average. Once in a blue moon, they might win one of the prizes, but on average, if you add up all the winnings and losses, it'll still average to be a loss. Okay, any questions?
I feel like negative 2.2 is too low. Cause,
I got negative 2.8.
yeah.
Yes.
Oh, okay, yeah, maybe that, yeah, so make sure that you enter this in, so, yeah, maybe it might be
Negative 2.2.
okay. Alright, any questions? Okay, so what we've done is so far, we've talked about what a probability distribution is, and we talked about how to find the mean of a probability distribution.